Graphing a logarithmic function. This problem can be found in section 8-3 on page 449. And this is quick check problem number 6. The problem states, graph y equals log base 3 of x plus 3. There are two ways you can go about doing this. The one they teach you in the book is to use the parent function of a logarithmic function. However, another way to do it would be to undo this equation here, this logarithmic equation. Because we know that log base b of y is equal to x, and we know this equation right here is directly correlated with y equals b of x. And this can be found on page 447 if you need a refresher. So then we know that this equation here is the same as this equation here. So then, what we need to do is take this equation and transform it into an equation like this. So, we need to find out which part of this equation is the x, the b, and the y. We know that the y in this case is the x. We know the 3 in this case is the b. And we know the x plus 3 is the y. So then we just need to fill in the x, the b, and the y to the new equation, y is equal to b to the x. So we put in 3 to the y is equal to x plus 3. And so this is our new equation. And from this, we already know how to graph it. So then we can just make a table with these values. If we plug in, and so then one other thing we need to remember now is that we're trying to solve for y. So we need to find that we're trying to solve for x. So we need to find the y values instead of the x ones that we usually find. So for y, we'll plug in -1, 0, 1, and 2. And so then once we plug this into our calculator, we do -3 to the negative first power, which would be 1/3. And then you know that 1/3 is equal to x plus 3. So you subtract 3 from both sides, and you get -2 and 2/3. Next, you put 3 to the 0th, which would be 1, and then you know that 1 is equal to x plus 3, and then when you subtract 3 from both sides, you get -2. And then when you plug in 3 to the first power, you know that it's 3, so then you know that 3 is equal to x plus 3, and then you subtract 3 from both sides, and you get x is equal to 0. And finally, when you plug in 2 to the in for y, you get 3 to the second power, which is 9, equal to x plus 3. Then you subtract 3 from both sides, and you get x is equal to 6. So now you have your table of values, and now the only thing left to do is to graph it. When making your graph, you can set it up whichever way you would like. I'm setting mine up by going by 2's on the y-axis, and 2's on the x-axis, and 1's on the y-axis. This is 2, 4, 6, -2, -4, -6. This is 1, 2, 3, 4, etc. -1, -2, -3. So now when we plug in our corresponding values, we first have to plug in -2 and 2/3 and -1. So we go to -2, and this would be 3 here, and 2/3 and -1. Next, we have to go to -2 and 0. Next is 0 and 1. And finally, 6 and 2. And then we have to make the curve. And if we were to continue this graph by plugging in x values such as, or plugging in y values such as -2, -3, and keep going down, what would happen would be the x values would continue to approach -3, but it would never touch -3. So we know once we make our curve that this would be our graph, of course, and then the vertical asymptote, because we're solving for x in this case, would be x is equal to 3 instead of y is equal to 3 if we were solving for y.